Hi everyone, welcome to 7.5. Today's focus is going to be long division. Okay, so before we jump into long division of polynomials, let's just do a quick review for long division with some numbers. All right, so if we're taking 697 and we're dividing by 4. All right, so 4 will go on our outside and 697 goes underneath. All right, so as we go through, we kind of ask ourselves, all right, how many times does 4 go into 6? Well, 4 goes into 6 one time, all right? And then what do? Well, we're going to multiply. So 1 times 4 is going to get us 4 underneath. So we will have 4 here. And now what we do is we are going to subtract, okay? So 6 minus 4 is 2, and then we just bring the other guy on down. Now we go through the process. What times 4 gets us to 29? Or 29, 4 goes into 29 how many times? And hopefully we recognize that's 7 times. So 7 times 4 is where we get 28 from. And now we just have to subtract that quantity. And so 29 minus 28, we get a 1. And now I bring the last guy on down, 17. So now we go through the process again. 4 goes into 17 4 times evenly. 4 times 4 is going to be 16. Now we're going to go ahead and subtract. 17 minus 16 is 1. So this actually becomes the remainder. But how do we actually write our answer? Well, 697 divided by 4 is going to be 174 and a remainder of 1 over 4, what we were dividing by in the first place. Okay, so that's just a quick reminder with numbers, but now let's go ahead and try dividing polynomials. All right, so the key when we're dividing polynomials is, well, this x plus 2 goes on the outside, okay? The polynomial, the numerator, goes underneath that division symbol, that long division symbol. But before we do, I want to make sure that we have every term accounted for. Meaning, I notice we have a degree 3. That means we need a degree 2 term, a degree 1, and a degree 0. In this case, we have all of those accounted for, so we don't need any placeholders. If I was missing one of these terms, and you'll see in an example later on, we would need what's called a placeholder. But we'll get to that when the time comes. In the meantime, let's go ahead and get started. So we're going to have x cubed minus 2x squared minus 3x plus 12 underneath our division. Okay, so I still ask myself kind of the same thing. X times what gets us x cubed? So hopefully we recognize, oh, x times x squared. So now we're going to multiply this x squared by each thing over here. So x squared times x is where we get x cubed. X squared times 2 is where we get plus 2x squared. But now what we do is we go through and we change the sign of everything because we're subtracting these quantities. All right, the goal is that those x cubes cancel that first term, which they do. And so what are we left with? Well, we are left with negative 4x squared, and I'm going to bring everything on down now. So minus 3x plus 12. Since it's a polynomial, I'll bring every term down. Now we go through the same thing. Well, x times what gives us negative 4x squared? So hopefully we recognize, oh, x times negative 4x is going to get us negative 4x squared. So now we can go through the multiplication again. Negative 4x times x, we get negative 4x squared. Negative 4x times 2, we get minus 8x. But we now have to subtract this quantity. So I just go through and I change the sign. Instead of minus, it becomes a plus. And I circle it as well so that I know I already changed those signs. And now we just carry out the operation. So the 4x squareds go away, and we're left with 5x, and I'm going to bring that plus 12 on down. And now, lastly, we go through and say, okay, x times what gives us 5x? So x times 5. So we're going to have a plus 5 up here. And now we go through and we multiply. 5 times x gives us 5x. 5 times 2 gives us a plus 10. But now we have to change our signs because we're really subtracting this quantity. And when we do, the 5x's cancel, and we're left with 2. So this is our remainder. So how do we go ahead and state our final answer? Well, our final answer is going to be the green portion on top, x squared minus 4x plus 5. But now how do we take into account that remainder? It's going to be a plus 2 over, what were we dividing by? X plus 2. So there is our final answer here. Okay? All right. What I want you to do is I want you to try this example here. Okay? The key, again, we don't need any placeholders. A degree 3, I've got a degree 2, I got a degree 1, and a degree 0. But now this time we're dividing by 2x minus 1. So I'll get us started. So the 2x minus 1 goes on the outside, and now we have 2x cubed minus 3x squared plus 7x minus 3 underneath. Okay, so go through, carry out the operation, and pause the video. Come back when you're done, and let's see how you did. Okay, how'd you do? So again, first thing I ask is I say, okay, 2x times what gets us 2x cubed? And that's going to be x squared. Multiplying both of those terms by x squared, and then changing our sign, which is what's in red. Carry out the operation and bring down the other guys. So negative 2x squared plus 7x minus 3. Now I ask, well, what times 2x gives us negative 2x squared? That would be negative 1x. Multiply negative 1x times 2x minus 1. We get negative 2x squared plus x. Changing the signs because we have to subtract the quantity. We're going to be left with 6x, bring down the minus 3. So now last I have to ask myself 2x times what gives us 6x? And that's going to be a plus 3. When we multiply 3 by both of those blue, we get 6x minus 3. Changing the signs, we get a remainder of 0. So our ultimate answer here is going to be x squared minus x plus 3. It simply means that 2x minus 1 goes into that polynomial evenly. Another way that we can talk about it is 2x minus 1 is a factor. All right, so this guy is a factor, and we'll talk more about that later on. It goes into that polynomial evenly. Okay, let's move on to the very last example. And now we're taking a quadratic. We're dividing by a quadratic, okay? But what we should notice again is we always look for placeholders. So now we have a degree 4, which means I need a degree 3 term, which we don't have. We have a degree 2. We don't have a degree 1, but we have a degree 0. So we're actually going to need 2 placeholders in this guy. When we're dividing, I have a degree 2, a degree 1, and a degree 0 term. So we don't need any placeholders in what we're dividing by. So that's going to go on the outside. So we're going to have x squared plus x plus 1. So we're good there. Okay, underneath, we're going to have x to the 4th plus, we need a placeholder, 0x cubed. All right, so there's 0x cubes, but we need that placeholder so all of our terms line up nicely. Then we have plus x squared, but we need another placeholder for the 0x. And then finally we have the plus 1. So now we can carry out this operation. Very similarly to before, the only difference is now we're dividing by 3 terms. So again, we ask ourselves, okay, x squared times what gets us x to the 4th? So we should say, oh, x squared times x squared. But now we multiply that guy to all 3 terms here. And when we do, x squared times x squared gets us that x to the 4th. X squared times x gets us a plus x cubed. X squared times 1 gets us a plus x squared. Now we change the signs because we're subtracting this quantity. And what's going to happen? The x to the fourths cancel. We have negative x cubed. The x squareds cancel as well, so we now have 0x squared. And now we just bring these other guys on down. So plus 0x plus 1. We always want to keep those placeholders to help align everything. All right, now we have to go through and say, okay, x squared times what gives us negative x cubed? So we should say, oh, x squared times minus x. So negative x goes next. We're going to multiply everything through by negative x. We get negative x cubed. Negative x times x, we get negative x squared. Negative x times 1, we get negative x. So now we go through, we change these signs because we're subtracting this entire quantity, and we carry out the operation. So now we have 0x squared plus x squared, which just gets us 1x squared. 0x plus 1x, we get 1x, and then we bring that plus 1 on down. All right, lastly, we have to ask ourselves, well, x squared times what gets us x squared? Well, hopefully we recognize it's just a plus 1. And now we're going to multiply 1 by all of those blue terms. 1 times x squared gets us x squared. 1 times x gets us plus x. And 1 times 1 gets us plus 1. So we go through, we change all of our signs because we're subtracting this quantity. And what happens? We get a remainder of 0 again. So now we just have to state what our overall answer is. So when we divide x to the fourth plus x squared plus 1 by x squared plus x plus 1, we get x squared minus x plus 1 as our answer. And again, since we get a 0 remainder, this means that this polynomial goes into x to the fourth plus x squared plus 1 evenly, which means it is a factor. Okay, and again, we'll talk more about that idea later on, but it's a good start. If you have questions, let us know.